Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 5, Lesson 19. Let's get started. Okay, in the opening exercise, we're asked to know the difference between surface area and volume. So the first one, the first question says a box needs to be painted. How many square inches need to be painted to cover the entire surface of the box? And since it kind of gave me a few hints, square inches implies area. So I'm going to find the surface area, the area of all of the surfaces of the box in order to find out how much needs to be painted. So this is where we did front, back, top, bottom, right side, and left side. We find the surface area. And if we do the front, that's a 15 by 6. So these two together is going to be a 15 times 6 times 2 to account for the front and the back. The top and the bottom is going to be a 15 by 12. 15 by 12. So these two together are going to be 15 times 12 times 2. And then the right and the left side are 12 by 6 rectangles. 12 times 6 times 2. And then we can use our calculator to find out what the surface area is. 15 times 6 times 2 is 180. And then 15 times 12 times 2 is 360. That's the top and the bottom. And then the right side is a 12 times 6 and then times 2 to get the right and the left. That's 144. And when you add those all together, you'll have surface area. So there's 18, carry the 1, and that's 6. So 684 inches squared. That is the surface area of the first box. Now, they give us a juice box, and they want to know how much juice fits inside the box. Well, the space inside of a three-dimensional object is volume. So remember, volume is equal to the area of the base. In this case, it's going to be length times width times height. So volume is 4 times 1 times 2. 4 times 1 is 4. 4 times 2 is 8. So this is 8 inches cubed because that's volume. Remember, surface area is given in square inches. Volume is given in cubic inches in this case, cubic units. All right. So example 1, Vincent puts logs in the shape of a rectangular prism outside of his house. However, it's supposed to snow and Vincent wants to buy a cover so the logs stay dry. If the pile of logs creates a rectangular prism with the following measurements, what's the minimum amount of material needed to cover the pile of logs? So we got to think about this for a second. It is going to be a rectangular prism. However, we don't want a bottom. We don't want to put them inside of a rectangular prism. We want it to cover the left side, the right side, the front, the back, and the top, but not the bottom. That's going to be open. So we're going to be smart about this. We're going to go front, back, definitely going to do that. Just the top, no bottom, and then a right side and a left side. Those two will be together. So let's see. 33 long. Let me just draw us a little sketch. 33 long. 12 wide would be this dimension. So 33 by 12. And then it's going to be 48 centimeters high. So that's going to go here, 48. And so this is what it's going to look like, roughly. Okay, if I draw this sketch, it's going to be something like that. And then we'll see the bottom. If we look through, we'll see the left side and the back and the bottom. But we don't want to count that bottom. So let's do the front and the back. The front is a, let's get another color. The front is a 33 by 48. So we're going to do 33 times 48 times 2 because we will use the back. The top is going to be a 33 by 12. So that's just 33 times 12. No bottom. So we'll leave that. We're not going to multiply by 2 because we don't have a bottom. And then the right side is a 12 by 48. So this is 12 times 48, and we will multiply by 2 because we want the left side as well. All right, and then we're going to use the calculator again, some big numbers here. 33 times 48 times 2 is, let's put that here, 3,168. And then 33 times 12 is 396. And then 12 times 48 times 2 is 1,152. And now that includes front, back, right side, left side, and just the top. And when we add those all together, let's add those up. 396 plus 3168 plus the 1152 is 4,716 centimeters squared. 4,716 square centimeters will be the amount of material to cover the pile of logs. All right, to the exercises. We got to remember volume and surface area here. Number 1, Quincy Place wants to add a pool to the neighborhood. When determining the budget, Quincy Place determined that it would also be able to install a baby pool that required less than 15 cubic feet of water. Quincy Place has 3 different models of the baby pool to choose from. So those are the 3 different dimensions. Which of these choices is best for the baby pool, and why are the others not good choices? Well, let's try these out. First of all, it's got to be less than 15 cubic feet, and that implies volume. So I'm going to find the volume of each one of these. The volume of choice 1 is going to be 5 times 5 times 1. That's 25 cubic feet. So that's too much. That's too big. So choice 1 is no good. Choice 2 is 4 times 3 times 1. That's 12 cubic feet. So that's a possibility. And then the last one is a 4 times 2 is 8 times 2 is 16. 16 cubic feet is also too big. So the only choice here is choice 2. It's the only one that has less than 15 cubic feet of water. Okay, so that's a volume question. Number 2. A packaging firm has been hired to create a box for baby blocks. The firm was hired because it could save money by creating a box using the least amount of material. So that sounds like surface area. The packaging firm knows that the volume of the box must be 18 cubic centimeters. So our box has to be 18 cubic centimeters. So that means when I multiply length times width times height, it has to be exactly 18 cubic centimeters. So let's think of some ways that we can multiply to get 3 numbers, 3 dimensions to get 18. We could do 1 times 18. Okay, that would be 18 cubic centimeters. We could do 1 times 2 times 9. That would work. 2 times 9 is 18. So that's a possibility. We could do a 1 times 3 times 6, that's 18. Let's see, if we made this a 2 times 2 is 4, and then I can't multiply, so not times 2. How about times 3? That's 6, and then I could multiply again times 3, and that would be 18. 2 times 3 is 6. 6 times 3 is 18, so that would work. So we've got 4 possibilities, it looks like, and we want to use the least amount of material. So we want the one that has the lowest surface area. So if I find the surface area of all 3 of these options, let's call this option A, this one's B, this one's C, and this one's D. If we find the surface area of all 4 of those, we'll be able to tell which one has the least amount of material. So let's start with option A. We'll do that over here. And surface area of this box is going to be, well, let's use that formula. Let's go 2 times the length times the width plus 2 times the length times the height. So that's 1 times 18 plus 2 times the width times the height, and that's also 1 times 18. Okay, so when we get that, we get, well, this is 2, or sorry, that's 1, times 2 is 2, plus 18 times 2 is 36, plus 18 times 2 is 36. So we get 74 square centimeters for that surface area. Okay, let's do B. Let's see if we can fit all these on here. B would be 2 times length times width plus 2 times length times height plus 2 times width times height. Okay, so let's see. 2 times 2, that's 4. And this is 9 times 2, that's 18. And then we have 18 times 2, that's 36. So 36 and 18, that's 54, plus another 4 is 58. So this would be 58 centimeters squared. That's a little better. It's using less material. Okay, C. Let's try C here. C would be a 2 times 1 times 3, length times width, plus 2 times length times height, plus 2 times width times height. And let's see, we've got 3 times 2, that's 6, plus 2 times 6 is 12, plus 18 times 2 is 36. So on this one, we get 48 and 6 is 54. So that's even better, 54 centimeters squared. So that's even less material. And then we have one last option. Let's try that one. D, option D. Option D would be 2 times length times width plus 2 times length times height plus 2 times width times height. And let's see, 6 times 2 is 12, plus 6 times 2 is 12, plus 9 times 2 is 18. So 24 and 18 would be 42 centimeters squared. So clearly the best one is option D. And if you notice, if we go back to option D here, that's really close to a cube. You know, it's only 1 centimeter off. The length is only 1 centimeter away from the width and the height, and that created the least amount of surface area. So if we can make our box as close as we can to a cube, we'll use less material in making the box. All right, so that one was a 2 by 3 by 3 centimeter box. All right, number 3. A gift has the dimensions of 50 centimeters by 35 centimeters by 5 centimeters. You have wrapping paper with dimensions of 75 centimeters by 60 centimeters. Do you have enough wrapping paper to wrap the gift? Well, we have to find the surface area of the gift, so we're going to use those dimensions to find surface area. And let me go back and do this front, back, top, bottom, right side, left side. If we do the front and the back, let's say that's 50 by 35. 50 times 35 times 2. And then the top and the bottom, that might be a 50 times 5 times 2. And then the right side and the left side will be a 35 times 5 times 2. And now we've covered all of our surfaces, and we can calculate the surface area of the gift. So let's see, we've got 50 times 35 times 2, that's 3,500, and then we have a 50 times 5 times 2, that's 500. Okay, and then 35 times 5 times 2 gives us 350, and when we add those all together, we get 13.1, that's 4,350 centimeters squared is what we need to be able to cover the gift. Our wrapping paper is given to us in this dimension. It's 75 times 60. So 75 times 60 will be the area of our wrapping paper. 75 times 60 is 4,500 centimeters squared. And that's more than what we need, so yes, there is enough. Now, we may not be able to wrap it like a traditional gift where we fold the flaps in and so forth. It might have to be cut exactly. We don't have a lot of leftover, so it's pretty close. But we could definitely cover it with the wrapping paper that we have. All right. Number 4, Tony bought a flat rate box from the post office to send a gift to his mother for Mother's Day. The dimensions of the medium-sized box are 14 by 12 by 3.5 inches. What is the volume of the largest gift he can send to his mother? So since that's the volume of the box, if we can fill the entire box, that would be it. So we're just going to find the volume of this rectangular prism. So volume is equal to 14 times 12 times 3.5. And when I multiply those three dimensions together, that will give me the volume of the box. 14 times 12 times 3.5 gives us 588 inches cubed. That's the volume of the box, and that's the biggest volume gift that he could send. All right, number 5. A cereal company wants to change the shape of its cereal box in order to attract the attention of shoppers. The original cereal box has dimensions 8 by 3 by 11 inches, and the new box the cereal company is thinking of would have dimensions 10 by 10 by 3. Which holds more cereal? Well, that means volume, so we need the volume of both. So here's the original box is 8 times 3 times 11. So the original box, 8 times 3 times 11, that's 24 times 11, is 264 cubic inches. That's the volume of the original box. And the new box is a 10 by 10 by 3. So that's 100 times 3, that's 300 inches cubed. So the new box would hold more cereal. Okay, the new box would hold more cereal, 300 cubic inches versus 264. Which box then requires more material to make? Well, that's surface area. So let's do surface area of the first box. Well, the surface area of the first box is going to be 8 times 3 times 2 plus 2 times, what did I do there? Plus 2 times 8 times 11 plus 2 times 3 times 11. Okay, and that gives me top, bottom, front, back, right, left. And when we do that, we get 24 times 2, that's 48, plus 88 times 2. 88 times 2 is 176, plus 33 times 2 is 66. So let's add those together. 48 plus 176 plus 66 is 290. So the original box would be 290 square inches for surface area. All right, and then let's figure out the surface area of the new box. The new box is going to be 2 times 10 times 10 plus 2 times 10 times 3 plus 2 times 10 times 3 again. And 10 times 10 is 100, times 2 is 200, plus 10 times 3 is 30, times 2 is 60, plus another 60. So 260, 320. So that's 320 square inches to make is the surface area of the new box, which requires more material to make. The second box requires more material because it has a larger surface area. All right, so we're keeping track of the difference between surface area and volume. Number 6, Cinema Theaters created a new popcorn box in the shape of a rectangular prism. The new popcorn box has a length of 6 inches, width of 3.5 inches, and a height of 3.5 inches, but does not include a lid, so we're not going to have a top. This time, no top. So let's do this. Let's go. We're definitely going to have a front and a back. We are going to have a bottom but no top, and then we're going to have a right side and a left side. And remember, the front and the back are going to be the same, the right and the left are going to be the same, and then we'll add it up to find the surface area. Front is a 6 by 3.5, so this is 2 times 6, that's not a 6, 6 times 3.5. And the bottom is going to be a 6 by 3.5, so 6 times 3.5. And we won't multiply by 2 this time because we only want the bottom. And the right is a 3.5 by 3.5. So that's 2 of those, 3.5 times 3.5. Okay, so we've got all of our calculations here, and we can multiply. Let's see, 2 times 6 times 3.5, that's 42. So I'm going to put those down here so we can see them. 42 is the front and the back. A 6 times 3.5 is 21. That is the bottom. And then 2 times 3.5 times another 3.5 gives us 24.5. And that is the right and the left side. And when we add those up, we get 4, 6, 7, and this is a 8. 87.5 inches squared. That's going to be the surface area of the popcorn box. And then we'll need to know how much popcorn it holds. So the amount of popcorn it holds, if we fill it right to the top and no overflow, will be the volume. So we're going to do volume equals length 6 times width 3.5 times the height 3.5. And that will be the volume of the popcorn box. So when we multiply 6 times 3.5 times 3.5, we get the volume is equal to 73.5 inches cubed, because it's volume. So surface area, 87.5 square inches, volume, 73.5 cubic inches. Okay, remember when you're finding area, it's squares. Square, two-dimensional squares will cover a two-dimensional surface, and three-dimensional cubes will cover a three-dimensional surface, fill a three-dimensional surface, three-dimensional object, and that's the difference between surface area and volume. All right, hope that helps. Lesson 19. See you next time.